This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're continuing, just graphing lots of trig functions. There's so many different types. We're still on the sine function right here. And we're going to do this problem. So we're asked to determine the period, amplitude, and vertical shift, and then graph it. Now there's two ways to determine the period. One is you use the formula 2 pi over b. So remember the period is 2 pi over b, so I have to know what b is, and in this case you look at always the coefficient of x, which is 3/2, right? You have to think of that as 3/2 x. So b is 3/2. So 2 pi over b, remember, is the same thing as 2 pi divided by b, which might be easier since we are dividing by a fraction. So if I wanted to find the period, we could do 2 pi divided by 3/2, which is 2 pi times 2/3, because you multiply by the reciprocal, and we get 4 pi over 3. So this is our period. All right, if you don't want to use the formula, what you say is you say what's in the parentheses here, the 3x over 2, right? And the sign usually goes in between 0 and 2 pi, and what you do is you solve for x to see what the period of this goes between. So I need to isolate x, so I multiply both sides by 2/3. And that says I get x is between 0 and 4/3, 4 pi over 3. So again, if it goes between 0 and 4 pi over 3, I'm going to have my period of 4/3. So no matter how we look at it, our period is 4/3 pi. I'm sorry, 4 pi over 3. Okay, so we've done that. Now we're also asked to state the amplitude and the vertical shift. Those are actually a little bit easier. Let's put this up. Amplitude. The coefficient of the function, sine, is -1. It's just the absolute value. So the amplitude is still 1. And the vertical shift. Right, vertical shift. We've got something plus 1. So everything is shifted up 1 unit. So the vertical shift happens to be up 1 unit. So now we're ready to find our key points and graph. All right, so here's our function. We want to get the x and y values here. And so how do we find the x values? We know it goes between 0 and 4 pi over 3. So we know it starts at 0 and ends at 4 pi over 3. If you want to look at the picture, that means if you start here, you end at 4 pi over 3 to get a complete cycle. All right, so the question is, what are these points here? And to get our first x-coordinate after 0, that's 1/4 of the way to 4 pi over 3. So that's how I like to do it. I just say it's 1/4 of the way there, so it's 1/4 of pi over 3. And that is simply, if you cancel the 4's, pi over 3. So our next x-coordinate is pi over 3. And then we keep adding a 4th more to get our next spot. So for instance, here's pi over 3. What's the next place going to be? That's pi over 3 plus another pi over 3 is 2 pi over 3. Pi over 3 again is 3 pi over 3. Pi over 3 again is 4 pi over 3, which is what I wanted. And those are the same things that go over here. 2 pi over 3, 3 pi over 3. Now I know that is pi. If you want, you could write pi. And 4 pi over 3. I'm just writing them all with a common denominator. Okay, so those are going to be our key x-coordinates, right? Now we need to find the y-coordinates. Here's where we remember what the usual values are for x and sine x. And what we're really concentrating on right now are the y values. Remember, it goes 0, 1, 0, -1, 0. And the point is, by putting in these values of x in here, we're really going to be taking the sine of these actual values after you do 3 halves times it. And so we're going to do a negative times what that those usual y values over here, negative times whatever that sine of 3x over 2, which we know what they'll be. They are 0, 1, 0, -1, 0. Those are those y values right here, right? And then what do we have to do? We have to add 1, right, to each of those. So let's compute. -0 plus 1 is 1. So my first order pair is going to be at 0, 1. -1 plus 1 is 0. -0 plus 1 is 1. The opposite of -1 is 1, so I have 1 plus 1 is 2. -0 plus 1 is 1, and so there are my 5 ordered pairs that I want to put on the graph. So now we're ready to graph. All right, so on the x-axis, to get a full cycle, we have to go to between 0 and 4 pi over 3. So that's what's so cool about graphing. You get to label your x and y axis, and you must label them. So I'm going to go on my x-axis, 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. There's going to be 4 markings until I get to this 4 pi over 3. Now, you can, if you want, label this pi, and then that's obvious. This is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. But be very consistent here. If we go to the left, that would be negative pi. So it's up to you whether you want to put a marking at every place, but you have to at least mark one place. And on the y-axis, we're going in between, what's the very smallest number is 0 and up to 2. So I don't have anything below the x-axis. It's only going up 2 spaces at the most. So let's graph these order pairs. We have 0, 1, pi over 3, 0. Okay, so the first place right there. Notice it's going down first. Why is that happening? Because of this minus sign in front of the sine, right? So that's why you see it starts going down first instead of going up like the regular sine function does. Then we have 2 pi over 3, 1. So it's the next place. I'm going here, right? Then we have 3 pi over 3, which is the same thing as pi, up 2 spaces. And 4 pi over 3, 1. So this looks like the sine function, except it's going down first, right? It's got that mirror image, right? It's flipped because of that minus sign. And if we wanted to keep going, we could do some more ordered pairs over here to get 2 cycles. And the last thing you want to do is make sure that you computed these right. So you might actually plug in one of these values for x into the original function just as a check, because it's easy to, kind of go on autopilot and make some arithmetic mistake. So for instance, if I wanted to plug in for x, pi, so I'm going to plug in, for instance, 3 pi over 3, which is the same thing as pi, I would be putting in 3, right? Let me do 3 pi over 2, this is equal to negative, plus 1. All right, and actually compute it. So that's negative the sine of 3 pi over 2. So what's the sine of 3 pi over 2? Remember what that looks like? It's down here at 0, -1. The sine is -1. So that's the opposite of -1 plus 1, which is 1 plus 1 or 2. And that's exactly what I had. Pi 2 was a correct ordered pair. So this is just a little check you might do. It's up to you, but I suggest that, especially if you're taking a test. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.